Good morning, learners. We'll be having basic science for GSS 3 this morning, and we'll be looking at the topic sound energy. Sound energy. We've said energy is the ability to do work. The ability to do work is what we've termed as energy. So, under the type of energy, we have sound energy, nuclear energy, electric energy, mechanical energy, and all of that. But today we are looking at sound energy as a case study. Our performance for this class is we should use objects to produce sound by making them vibrate. And two, we should explain loudness and amplitude. And thirdly, describe pitch and frequency. Should describe pitch and frequency. Firstly, let's see the next one. Let's see how vibration produces sound. How vibration produces sound. Sound is made by vibration. A vibration is a shaking motion. When an object such as a radio speaker vibrates, it is stretched and squashes the air around it. What we are trying to say here is that any object that is in a shaking motion is said to be vibrated. A perfect example for this is that we can use is the radio. When you turn on the radio, if the volume is on the higher side, the type of sound it will produce might make the radio to move, might make the radio to be shaking. And once it is like that, vibration is said to have occur. Vibration is said to have occur. And even if you turn on your speaker and it's on the higher side, on the higher volume too, if you put any object close to it, the object tends to move, so it can begin to shake. So once that happens, vibration is producing sound, because when it is moving, it's going to be making sound. Now let's look at I think before we look at the object, let's look at the meaning of loudness and amplitude. Loudness and amplitude. The loudness of a sound depends on the size of the vibration. The loudness of a sound depends on the size of the vibration. If the object that is shaking now, that we said to be in vibration, if the sound close to it is on the louder side, that is how you also that is when you will know that the object that we're talking about, that we said depends on the size of the vibration, is now called the loudness. So the loudness of a sound depends on the size of the vibration. If loud sounds are big vibration, and soft sound are small vibration. If the sound is very loud, objects that will vibrate now will be in a big vibration. It's not just going to be vibrating in a little way, it's going to be vibrating very well, to be on the higher side, because the sound is very loud. And as for the case of soft sound, if the sound is not that very loud, it's going to cause small vibration. So when you pick an object close to a speaker, if the speaker is very loud, the object will have a small vibration. But if the speaker have a soft sound, then the object will have a small vibration as well. Now the amplitude now is half the height of the sound wave. What we are calling the amplitude here is half of how loud it is or how soft it is. Now let's look at how we can make use of bottle to make sound. The procedures are very simple. You have to set up a group of bottles filled with different amount of water. Let's say bottle A, B, and C. The first one, you fill it to the brim, you fill it to the fullest. Then the second one, make it like half of the bottle, fill it with half of the bottle of water. Then the third one, you can decide to put a quarter of the bottle. You can decide to put the water that will get to the quarter of the bottle. Then after that, blow over the lips of the bottle. As you are blowing, begin to take your observation. Look at it. Which bottle have the higher pitch? Which bottle have the higher pitch? Okay, this is a diagram of loudness and amplitude. This is it. This is how big it is, how loud it is, and this is just half of it, dividing it little by little. Now, pitch and frequency. Some sounds are squeaky and some are deep. The pitch of a sound depends on the rate of vibration. Pitch that I'm talking about when I said the third thing you should observe in your using of bottle to make sound is that which bottle have the higher pitch. The higher pitch now is talking about which bottle produces a larger sound, and how far does the sound travel. Is it just boom and it stop, or is going like boom, like it's going higher? That is what we're trying to talk about. So I said some sounds are squeaky and some are deep. When I said some sounds are squeaky, that means it is producing high pitched. The sound is very high, and some that are deep are producing low pitch, which means the pitch is very high. The pitch of a sound also depends on the rate of vibration. Depends how it vibrates. If it vibrates very deep, if it vibrates very slow, very soft, or very loud, then that is when you can decide what the pitch looks like. Now, the number of sound vibration per second is what we call the frequency. For example, if I put maybe a plastic cup beside a speaker, and as the speaker is making sound, making a very loud sound, the plastic tends to begin to shake. As it is shaking, the frequency now is how it is shaking per second. If it can shake twice in 1 second, that if you calculate it, that will be the frequency. Okay, this is another diagram. Don't mind my diagram, I'm not good at drawing, I'm sorry. Okay, this is a drum set. As you can see here, the one having 2 sticks on it, that's a drumstick, the drum set. Now, if you are beating this drum, if you beat it very slow, it depends on how you want it. And if it is as well, if you as well hit it hard, it also depends on how far the sound is going to travel. So those are the things. You can use any other object to learn about sound energy, how you can produce sound. In summary and conclusion, okay, we need to know that sound travels. So when you do your practicals, when you take other objects to see how sound travels, then you will know how you can derive your observation from it. Don't forget, sound energy is a form of energy, but it moves differently from that of light. And there is a way the ear can also hear sound. I would like us to go about it and see how possible is that. Your assignment: how does sound travels? How do you think sound travels? Explain, send your response. I'll be waiting to have them so we can continue from there. Thank you.